This is the Split Check Calculator Project Challenge, and the learning objectives for this project challenge are very similar to the other one for this week. The students should be applying variables and expressions. They're taking input from the user and processing that, and then practicing applying sequence to solve a problem. So let's take a look at the basic directions for this project challenge. So the students are challenged to write a program to calculate the amount each person must pay towards a bill at a restaurant. And that's going to include the amount they pay towards the tip and the amount that they pay towards the food bill. So, and a group of friends are going to be eating together. And they're going to split the costs evenly. The program is going to take 4 inputs: the restaurant bill without tax or tip as a floating point number, the sales tax rate as a floating point number, so an 8% tax rate would be 0.08. Then the level of service is an integer between 0 and 10, 0 meaning a 0% tip, 5 meaning a 15% tip, and 10 meaning a 30% tip. And then the last input is the number of friends to split the check among. So the first 2 inputs are going to be floats, and the second 2 inputs are going to be ints. And then the program should calculate and then output the amount each friend should pay towards the bill with tax, and the amount each friend should leave in tip. The tip is going to be calculated on a pre-tax restaurant bill. The total amount each diner should pay, including the restaurant bill, sales tax, and tip, should also be outputted. And the overall total, which includes the restaurant bill, the sales tax, and the tip. So a lot of things for the students to put together here. There's a sample input and output, so you run this and the user inputs $35 for the bill and an 8% sales tax rate, service level of 7, and 3 friends, and the output should be very similar to this. The per person bill with tax, $12.60, the per person tip, about $2.45, total per person, $15.05, and the total bill including tax and tip, $45.15. This mentions that their specific results might be off by a fraction or so, and that's okay. We're not asking for them to be perfect on the rounding elements of floating point numbers. So as long as they're within, 0.5 of the expected answer, we should consider that to be okay. Things that we ask the students to pay attention and look out for and apply: follow the basic recipe of first collecting the input, then doing the processing that you need to do to determine the outputs, and then lastly display the outputs. We're not going to force them to do this, but it's a good recipe that we would like to encourage them to follow. We want them to spend some time choosing their variable names carefully and naming sub-expressions where that sub-expression might be a little complex, and take advantage of the variable names to kind of make non-obvious computational steps more obvious. They should also take advantage of variable names by breaking any complex expressions down into simpler expressions and storing the intermediate values. So we'd like to see this growth in their ability to apply these concepts. The basic rubric has 3 components. There's a syntax component, which is 25% of their grade. This should largely be handled by the automatic grading system. And if they get full credit on that, that's fine. If the automatic grading system deducts points, you should take a look at that and make sure that the grade that they're given is appropriate according to the rubric. For correctness, there's a couple of tests that the automated system runs. If they get relatively correct outputs, within about a half a dollar, then they should be counted as correct outputs. Again, if it deducts any points, we should review that and make sure that the deductions are fair. And we should err in the student's favor. We want to try to find reasons to give them the most points possible, and then if there's anything they need to do to address the code they're writing or the techniques they're using, we want to put some comments to help them develop those skills. And the last part of the criteria is the style, which is also 25%, and this covers the naming of the variables, the use of variables to name things, and just basic organization of the code using white space. So maybe leaving a blank line between where they collect the inputs and then another blank line after they do their processing before they do their outputs, that kind of thing. There's a grading aid down here with templated feedback for you to use, some general comments, and then a target solution, basic idea: collect the inputs, process what you need to do to get the outputs, and then present the outputs to the user. So let's take a look at a couple of examples that students have turned in, and we'll see if we can't sort this out with the grading rubric. So here's an example, and this one's actually really interesting. I want to show you some features of the Vocarium tool, and you'll see that the score that this student was given, a 25 out of 25 for syntax. So everything compiles and runs. They got a 33 out of 50 on the correctness. So some of the outputs don't appear to be quite right, or possibly some of the outputs are missing. Use of variables, there's some potential problems there, but not very big ones according to this grader. And same thing for variable names and organization, 12 out of 15 there. So some small issues. And let's take a look at the comments that this grader left. They said it was a good attempt. You made a couple of mistakes, which is why your output numbers are wrong. Good use of variables and descriptive variable names. Your code organization is also good, but can be made better using comment lines to make it more readable. So this is an example of pushing the students to that next level. Naming your variables is great, but also it might be a good idea to put some comments in the code. And find more comments in your code. This is the feature that I wanted to point out that Vocarium allows us to do. So you'll notice when I click here to open the student's code submission, and you'll see these little talking balloons icon here. And you'll see that this grader has put comments directly in the student's code. And this is a feature that Vocarium allows us to access. If we just click in here and click, it opens up a nice little window where we can type in some comments, and you can see that it puts those comments in line in the code. So we can be very specific about what we're referring to. Here, you'll see the grader left a comment: restaurant bill variable needs to be cast to a float. It wouldn't matter for the test case given with the project challenge where the value is 35, but in general, restaurant bill can be a float value, so using float is more relevant. This is a great comment here. So the student is casting the input to an int, and that could cause problems if the actual restaurant bill was not a whole number of dollars. Here we've got a comment about the sales tax is also expected to be one of the inputs when the student, in this case, hard-coded the sales tax. So this would be referring back to the instructions, which explicitly note that sales tax should be taken as one of the inputs. So this is a great use of the tools available to us in Vocarium to give very targeted and very specific feedbacks to the students for their assignments. Let's take a look at another example student submission. We'll open this one up and take a look at the code. And when I'm looking at code like this, the first thing I'm kind of doing is just getting a sense for the neatness and organization. And this looks pretty great, you know. Some blank lines in between things, a couple of comments in here. It looks pretty good. And then I'm looking at the details. Here we're collecting the input. Here we're doing the calculation of the required outputs and then producing the outputs. This student is using a outputting technique that we've not taught, string formatting. So this is apparently a student who has more experience than we generally expect from students who are taking this course, but that's great. So they're collecting these first two inputs as floats, the next two inputs as ints, computing the tip rate, the bill after tax, and these variable names are fantastic. Bill per friend, bill after tax, number of friends. This is very descriptive, very detailed. Each step is broken down. This is fantastic. So I'm going to go over here and look and see what kind of a score this student got, and this student got 100% on all components. And we can take a look at the comments that the grader left. Excellent work, good code organization, good use of the variables, descriptive variable names, right expressions used, keep it up. And that's exactly the kind of thing that we want to do, is encourage the student to expand and extend themselves. Even when they do an excellent job, try to find some way to push them a little harder. So this is fantastic.